so I'm going to be explaining number 3. So first you have your equation h of x, and then you start with your possible rational roots. So you have plus and minus, and then on top goes the factors of your constant, which is 8. So it's 1, 2, 4, and 8. And then on the bottom, you do your factors of your leading coefficient, which is 1, 2, 3, 4, and 6, and 12. So once you have that, you're going to have to make it into one list. So you have your plus and minus, 1 over 1, 1, 1 over 2, 2, 4, and 8. And then you have 1 half, 2 over 2 is 1, 4 over 2 is 2, and 8 over 2 is 4. And then you have your 1/3, and then you have your 2 over 3, 4 over 3, and then 8 over 3. And then you come down with your 1/4, and then you have 2 over 4, which is 1 half, 4 over 4, which is 1, and then 8 over 4, which is 2, which we already have those numbers. And then you have your 1/6, you have your 2 over 6, which is 1/3, and then you have your 4 over 6, which is 2/3, which we already have that too, and then your 8 over 6, which is 4/3, which we already have that. And then you do 12, 1 over 12. So 2 over 12 is 1/6, which we have that. 4 over 12 is 1/3, which we have that one too. And then 8 over 12 is 4/6, which is 3, I don't know, we already have that one. So you have, that's the end of your list. And so once you have all of these, then you can pick and choose which ones you want to synthetically divide. So the first number that I chose to divide with was 1. So we can do 1 first. And then you write down each number to divide by. So you have 12, 53, 66, 12, and -8. So you drop down your 12, you draw your line. That was not a good line. So you have 12 down here, and then 12 times 1 is 12. So 53 plus 12 is 65. 65 times 1 is 65. So 65 plus 66 is 131. And you can tell these numbers are like getting really big, so this number will not work. So 131 times 1 is 131. Add that to 12, and you get 143. 140, oh, that's supposed to be a 3. Yes, 143. You times that by 1, and obviously it does not work out, and so that is not one that works. So we can erase this. We can cross that off the list. So after trying more numbers, I found out that -2 works. So we'll do -2 in our little box. And then you write down all your numbers, 12, 53, 66, 12 again, and then your -8. Drop down your 12 and draw your line. So 12 times a -2 is a -24. 53 minus 24 is 29. So 29 times a -2 is 50, -58. 66 minus 58 is 8. 8 times a -2 is a -16. So 12 minus 16 is a -4. And as you can tell, -4 times a -2 is +8, which gives us a 0. And we also know that -2, 0 will be a point. So once you have these numbers, you get to write a new equation. So I'm going to erase this and write my new equation. So I have 12x, and so this was a 4th, now this is going to be a 3rd. So 12x to the 3rd plus 29x to the 2nd plus 8x, and then -4. That's my constant. So now that we have that, I'm going to write -2, 0 right there so I can erase this. So now that we have our new equation, we notice that this is not a quadratic, and so we can't use the quadratic equation to factor more, and if we were to group, it wouldn't work out. Right? Wait. This is a 29. 29x. Okay. Now it will group. So now that once we have this, we have to do our possible rational roots again. So you have your plus and minus, and then you start again with your constant, which now is a -4. So now you have 1, 2, and 4. And then you have your 12, which is the same as the leading coefficient before. So you have your 1, 2, 3, 4, 6, and 12. So those are the numbers we get to choose from. So let's make it into one list. So it ends up to be 1, 2, 4, and then 1/2. 2 over 2 is 1, 4 over 2 is 2. Then you have your 1/3, your 2 over 3, your 4 over 3, and then you have your 1/4, and then you have your 2 over 4, which is a half, and then 4 over 4, which is 1, and then you have your 1/6, and then your 2 over 6 is 1/3, which we already have, and then you have 4 over 6, which is 2/3, we already have that, and then you have your 1/12, 1 over 12, which is our last one. So then we have those to choose from to synthetically divide. And so first we know that 1 didn't work in the big equation, so we can cross that off our list, but we still have -1. So that's the first one that I tried, was a -1. So we can try that. That's not a very good box. Okay, so now you write down the numbers for your new equation. So 12, 29, 8, and -4. So you drop your 12 and draw your line. So 12 times a -1 is a -12. 29 minus 12 is 17. 17 times a -1 is -17. 8 minus 17 is -9. And then -9 times a -1 is 9. So that leaves us with 5. So we know that is not a number that gives us 0. So that one didn't work. So we can cross that off the list. So, after trying more numbers, I found out that -2 worked again. So, I write my numbers, 12, 29, 8, and -4. Drop the 12, draw your line. So, 12 times a -2 is -24. 29 minus 24 is a 5. 5 times a -2 is -10. 8 minus 10 is 2, -2. And so -2 times a -2 is a +4, which leaves us with 0, which works. So now we know that -2 has a multiplicity of 2. That's important because it adds another root and it tells us that it touches and goes when we draw our graph. So after that, we can write our new equation. And since our last one was a 12x to the third, this one is going to be a 12x to the second, and then you have your 5 plus 5x minus 2. So this one actually factors, and we can use the AC method. So we have our AC, our AC is 12 times a -2, which is a -24. And our factors for -24 to get a +5 would be a -1 and 24, a -2 and a 12, -3 and an 8, which that works because that makes a +5. And so you write your 12x squared minus 3x plus 8x to break apart the 5 minus 2. After that, then you can group. So you have your 12 and your 3. That groups in, you can take out a 3x. So after you take out your 3x, you're left with a, what am I doing? You're left with a 4x, because of the squared, minus 1. Because you have to have the 1 because this whole thing is taken out and you have to represent it. And then for 8x and -2, you can take out a 4, or no, you take out a 2, and so now you're left with 4x minus 1. So make sure these are the same. So after that, then you have your 3x plus 2, taking it from right here, and then you have your 4x minus 1 from right here. So I'm going to erase this because we know we have that. So to bring this over here, we have to find the rest of our x-intercepts or our possible roots. So you have your 3x plus 2, and then your 4x minus 1. So 3x plus 2, set it to 0, and minus your 2 on each side. And so you have 3x equals negative 2, divide by 3 on each side, and you have x equals negative 2 over 3. That is one of our roots. So, but negative 2 over 3 is roughly a negative 0 or negative 6. Ooh. A negative, yes, is a negative 0.6. And that'll just help us graph later. And then you have your 4x minus 1 equals 0. So you add your 1 on each side. Add 1. And then you have 4x equals 1, divide by 4. X equals 1/4, which is like 0.25. So that will also help us when we graph. So now that we have our x-intercepts, so we have 1, 2, and then 3, 4. We can erase this, and now we need to know the end behavior of our graph. So our leading coefficient is 12, which means it's greater than 1, so it rises to the right. And then our DOP is a 4, which is even, so that means it has the same, it copies what the right does, so it rises to the left. So we'll have 4 roots, expected roots, which we do, the 1, 2, 3, 4, and then we'll have 3 expected turns. Because since this touches and goes, and these 2 go through, we'll have our 3. Cool. Oh, we need our y-intercept. That's important. So our y, so we have our x's, and we have our y-intercept. So you put a 0 in each place of the x, and when you multiply your zeros through, you end up with a negative 8. So your y-intercept will be 0, negative 8. And that's a multiplicity of 1, so that just touches and goes. So our x-intercepts, I'm going to write them down here. We have our negative 2, 0. This is multiplicity of 2. Yep, my chalk broke. Multiplicity of 2. And then we have our negative 2/3. And then we have our 1/4, 0. Okay, so now we have all of our points. We know exactly what our graph should look like, and we can actually graph it now. So I did my graph like this. I'm running out of room. Okay, so I did 1, 2, just so it's a little bit easier for us because we have fractions. And so here's a 0.5, so 1, 2, and then that's really as far as we need. And then up, I did 2, 4, 6, and then I did 8 on 2, negative 2, negative 4, negative 6, negative 8. Okay, so first we can put all of our points. So first we have negative 2 right there, which that again touches and turns. And then we have our negative 2/3, which is the right here, 0.6, which is a little bit more than the 0.5, a negative. And then we have our 1/4, which is right about here. That's our 0.25. So after that, then we know that this side goes up, and this side also goes up. And so we draw, this is a touch and turn right here. So let's not forget that. So this is going to start right here. It's going to touch and turn. It's going to go up. It goes through our negative, and it goes down. Oh, we have our -8. That's our y-intercept. That's important. So then it goes through our y-intercept of -8, and then it goes up. Oh, I don't like that sound. It goes up through our other x-intercept and all the way up, just like that. So our graph should look like that. We have our 1, 2, 3 curves, or 3 turns, as we should. We have our y-intercept of -0, -8, and then we have our 1, 2, 3, 4 expected roots. So yeah, that's it.